Now we're going to take up one more problem on composite bars. So here the problem we're going to read as it's the problem number 51. A weight of 300 kilonewton is supported by a short concrete of 250 mm square section. The column is reinforced with 4 steel bars of cross-sectional area 5500 mm square. Find the stresses in steel and concrete if ES equals 15 times EC. So that is the modular ratio is 15. If the stress in concrete must not exceed 4.5 meganewton per meter square, what area of the steel is required in order that the column may support of a load of 500 kilonewton? So here he has given the total load and also the concrete area of cross section and also the 4 steel bar of cross sectional area 5500 mm square. So we're going to see the figure here. This is a square of 250 mm and there is a 4 bar of 5500 mm square. So first we're going to analyze this. So first what we want the stresses in steel and concrete. So to do that, so what is the total cross-sectional area of the steel rod? The cross-sectional area of the steel rod is 5500 mm square. So but we want only the load on the concrete. So since the total cross-sectional area, since the steel is reinforced with the concrete, so naturally we want the cross-sectional area of the steel. So it's a cross-sectional area of the concrete only without considering the steel. So naturally you have to first calculate the cross-sectional area of the concrete with steel and minus area of cross-section of the steel. Then it will going to give you the total cross-sectional area of the concrete. So to do that, so 250 into 250, which is the square cross-section of the concrete, minus 5500, because that is the steel is reinforced in the concrete. So we want, since we want only the cross-section area of concrete, so you have to subtract the cross-section area of this steel. So once you do that, so on simplification, you will going to get that 57,000 mm square. Now since the column is reinforced, so the length of the column of both steel and the concrete will going to be equal. So what is that? The load carried by the steel rod plus the load carried by the concrete column will going to be the total load supported by the column. So here PS plus PC is equal to P. So that is the thing we will going to get. So what is PS? You express P in terms of sigma and A. So that is the stress and the cross-sectional area. So what is PS? PS is nothing but sigma S into AS plus PC. Substitute the P sigma C into AC, which will going to be the total load, which is 300 into 10 to the power of 3 because of 300 kilonewton. So once you do that, so here then we need to, and also what we know is the deformation in the deformation in the steel is equal to the deformation in the concrete. So what is that? The delta L is the general formula, which is P into L by A into E. Since it is for the steel, it will going to be PS into LS by AS into ES. So that should be equal to PC into LC by AC into EC. So that is what we do here. So that is what I have expressed here, PS into APS into LS by AS into ES, which is equal to PC into LC by AC into EC. So but we know what is PS into PS by AS, which is nothing but the stress. So which is sigma S into LS by ES is equal to sigma C into LC by EC. So that is what we need to write here. So that is once you do that, then we need to substitute the value of so here length of the steel rod and also the length of the column will going to be the same here. So naturally since LS is equal to ES, so naturally it is it cancels on either side of the both left hand side and the right hand side. So therefore sigma S into ES is equal to sigma C into EC. So but what we know is ES is equal to 15 times EC, that is sigma S by 15 times EC is equal to sigma C by EC. So since EC gets cancelled, so stress on the steel wire will be equal to stress 15 times the stress in the concrete. So once you do that, so now that is sigma S is equal to 15 times sigma C. So once you do that, now you're going to substitute the value of sigma S here in this equation, which is sigma S is nothing but 15 times sigma C into what is the area of steel? Area of the steel is 5500. So into 5500 is equal plus Sigma C into AC, sigma C you write it as it is into AC, area of cross section of the concrete. So since the area of the concrete only, it is 57,000. That will be equal to the total load, so which is 300 into 10 to the power of 3. So on simplification, you'll go to get the stress in concrete. So sigma C will be equal to 21.5 Newton per mm square. So stress induced in concrete, which is sigma C, will be equal to 21.5 Newton per mm square. Now, similarly, once you know the stress induced in the concrete, so naturally we can be able to find out the stress induced in the steel rod, because sigma S is equal to 15 times sigma C, which is already here. So the stress induced in the concrete is sigma C, which will be equal to 21.5 Newton per mm square. The stress induced in the steel rod, which is sigma S, which we need to find out. So this, since I know the value of sigma C, so here sigma S is equal to 15 times sigma C, which is 15 times 21.5. So that it amounts to 32.25 Newton per mm square. So once you do that, so here you're going to get, when the value of if sigma C is 4.5 mega Newton per meter square, so what is the load on this is 500 kilonewton, which is 500 into 10 to the power of 3, which will be equal to 5 into 10 to the power of 3. Sorry, 5 into 10 to the power of 5 Newton. So what is the area of steel, which we need to find out? Since it is the mega Newton, so 4.5 into 10 to the power of 6 Newton per meter square. Since the meter square, we need to convert that into mm. So 4.5 into 10 to the power of 6 divided by 10 to the power of 6. So once you do that, meter is 10 to the power of 3, the whole square. So that means 10 to the power of 6. So 10 to the power of 6 and 10 to the power of 6, you're going to get cancels. Therefore, we are going to get it as 4.5 Newton per mm square. So here, if sigma C is 4.5 Newton per mm square, what is the value of sigma S? Sigma X will be equal to 15 into 4.5, which is equal to 67.5 Newton per mm square. Once you know the value of sigma S, so what we know is sigma S into AS plus sigma C into AC will be equal to 5 into 10 to the power of 5. So now here sigma S is nothing but 67.5 into what is the area of cross section of the steel wire. So which we don't know, which we need to find out. Plus 4.5 into, so what is this 250 square minus AS? So here the value of 250 square minus area of the cross section of the steel rod. So this is the entire area minus area of the steel, which I need to find out, which is equal to 5 into 10 to the power of 5. So then on expanding, this 67.5 into AS will be plus 4.5 into 250 square, which leads to 281,250 minus 4.5 into AS is equal to 5 into 10 to the power of 5. So then on simplification, the area of steel what you are going to get it at 3,472.22 mm square. So this is how you will be able to calculate, or you will be able to find the solution for this problem. Thank you.